So we're going to find all the zeros of the function, and then we're going to identify each zero as rational, irrational, or complex. So we need to find the greatest common factor. And the greatest common factor is, what's the biggest number that divides evenly into 4, 16, and 12? And that number is 4. Last time I had said that the smallest is the greatest. The smallest x is the greatest. X3, X2, X. The smallest x is the greatest. Okay, we got 4x outside, factored out. And now we're going to go 4 times what is 4? That's going to be 1. X times what is x cubed? That's going to be x squared. 4 times what is negative 16? And that's going to be negative 4. X times what is x squared? That's going to be x. 4 times what is 12 is 3. And we took out the x, so there's no more x left. So now we're going to factor out the inside of this. And I am going to go straight to factoring without doing the x, because doing the x is for kids, little kids. And now we're all grown up. So x times x is x squared. Now I need to get these two numbers that multiply equal to 3 add up to negative 4. That's going to be what? Negative 3, negative 1? Yeah. Yes. Why? Because negative 3 times negative 1 is positive 3. And then I'm going to get negative 3x, and a negative 1x equals negative 4x. And x times x is x squared here. So now we got 4x. Bring it down, and we set it equal to 0. All right. Now, what do you plug in for x? This right here, this x. What number do you plug in for x? You multiply times 4, it will equal to 0. 0. Because if x is 0, that'll be 0 times 4 is 0. And 0 times anything is 0, so x must equal to 0. What can I plug in for this x? What can I plug in here that this quantity equal to 0? Positive 3. Why? Because 3 take away 3 is 0. 0 times anything is 0 times anything is 0. X equal to 3. And what do I plug in for this x? That when I plug it in, it works out to equal to 0. So x is 1. 1 minus 1 is 0. 0 times anything is 0. So x is equal to 1. So these are the zeros of the function. And they are all rational roots. So it has 3 rational roots or solutions. All right. So now, this is a third degree trinomial. This one is a third degree fournomial, 4 terms. So the way we do that one is not the same way we worked out this one. We are going to factor by grouping. All right. So what's the greatest common factor for x cubed minus x squared? What is the greatest common factor here? Well, automatically, if there's nothing in the front here, it's a 1, and there's a 1 here. It's just going to be a 1 in terms of the number. But in terms of the x's, the smallest is the greatest. So it's going to be x squared. So when I ask the question, between x cubed minus x squared, what's the greatest common factor? The answer is x squared. So now that we factored out x squared, what's left inside? X squared times what is x to the third? X squared times what is x to the third? That's going to be x. X squared times what is negative x squared? X squared times what is negative x squared? Negative 1. So what can I factor between 2x and minus 2? What's the greatest common factor? 2. 2. So we're going to factor out of 2. 2 times what is 2x?
1x.
Just x. 2 times what is negative 2?
Negative 1.
Now we went from having 4 terms to now having 2 terms. And I have this one and I have this one. So what's common between those two? They both have an x minus 1, and that's what I'm going to factor out. They're both going to give it away, x minus 1. So when you factor out x minus 1, What's left over for this one when you factor out the x minus 1? X squared. And what's left over for this one when you factor out x minus 1? Plus 2, yes? And we set it equal to 0. So in this one, we can do this one quickly in our head and say what x value plug in that the quantity equals to 0 when you work it out. X equal to what? What do you plug in for x that when you work it out, the quantity is 0? Positive 1, yeah? X equal 1, 1 minus 1 is 0, x is positive 1. Now, you would be extremely bright if you can give me the x value by doing it in your head. Who knows, who can do it? Who can tell me what the answer is here? Doing it in your head. All right, so this one's hard to do it in your head, so you're gonna actually have to work it out. So we're gonna have to solve. So how do we solve? What do I do? Minus 2, minus 2. So you're gonna have x squared equals negative 2. Now what do? Square root it, square root it, square root it. X is gonna equal to what? Plus or minus. I heard it. Square. Did somebody say square root of 2i? So this one has how many rational solutions? How many rational solutions? 1. How many irrational? None. How many complex or how many imaginary? How many imaginary? 2. 2 imaginary or complex. One rational, 2 imaginary solutions. Moving on. Today we're graphing polynomial functions by using roots and end behavior. Sketch the graph of each function. Let me give you 4 minutes to find the roots. In order to graph this without a graphing calculator, we have to find the roots. So go ahead and find the roots. This is like problem number 1 in the warm-up. So let me give you 5 minutes. Let me give you 5 minutes while you work on it. Okay, I told you 5 minutes, it's been 2 minutes or something, let's finish it. What's the greatest common factor?
4.
What's the biggest number that goes into 4, 8, and 4? I think it's 4. What else? The smallest x is the greatest? 4 is that x squared? Yes. 4 times what is negative 8? Is that negative 2x? Yes. 4x times what is 4x? Plus 1? Yes. I guess we can do the x here. Let's do the x. What was at the bottom? Is that negative 2? What was on top?
1.
What are the two numbers?
Negative 1 and 1.
Negative 1, negative 1? Yes? Negative 1 times negative 1, positive 1, negative 1 plus negative 1, negative 2. So then we're going to have what? X minus 1 times x minus 1. And then we got 4x equal to 0. Graph. We're supposed to graph this. And in order to graph, we need to find the roots. So the first root is at x equal to what? 0. And the second one, isn't 2 of the same answer? So this is a double root. So it's going to be at x equal to what? What do I plug in for x that the quantity is 0?
1.
Isn't it 1? Yes? But it's a double root. This is a double root. Double root. Because it has 2 of them. 1, 2. So now we're going to start graphing. So if I was to graph, first of all, do you remember what the first degree polynomial looks like, second degree, third degree? So a first degree polynomial looks like this. What does y equal to x look like? It's a straight line somewhere. So what does y equal to x squared look like? It's a parabola. It's a u. So what does y equal to x to the third look like? It's a sideways s that people don't believe, that they know it looks more like an N. So, well, yes, probably does look more like an N. So we're looking for something like this. This one would have one root or one solution here. This one would have maybe two solutions. This one has 1, 2, 3. But sometimes it has a double root. When it has a double root, it bounces. So let me show you now what it would look like. So when it has a double root, it will look like this. So when you graph it, it has a root at x equal to 0, at x equal to 0, right here. And then another root at x equal to 1, x equal to 1, this 1 here. And I know it looks like a sideways S or an N, so I know that it goes down, it goes up, I don't know where it turns around, and it will bounce at the double root, because it's a second degree. So it bounces there. When x equal to 1 is a double root, it bounces at that point. Here we go. Let's do this. Yes, got it? Moving on. Problem number 2. It's already a factored out. It's a polynomial that has been factored out. We don't have to do any work. What's the degree of this polynomial? What's the degree of the polynomial? We're in problem number 1 here. What's the degree of this first polynomial? The degree of this polynomial is what? Third degree polynomial. What's the degree of that problem number 2? What's the power of x if it doesn't have a number here on top? What's the degree here? 1. And what's the power of this one? 1. So what is 1 plus 1 plus 2? What's 1 plus 1 plus 2 is 4. So what do fourth degree polynomials look like? A W, thank you. You made me. So we already said that this is a third degree. If I turn it the other way, that's going to be a W. Fourth degrees look like a W. All right? So this is a fourth degree polynomial. So it has a single root Where does it have a single root at? We set it equal to 0. We set it equal to 0. What do I plug in for x that you multiply this x number by anything, it will equal to 0? So what is x? 0. So x must equal to 0. So because if x is 0, that means 0 times anything is 0. How about for this one? X equal what? -1. So these two are single roots. Now this one is a double root. Double root? Double root where? At x equal what? X equal to 3, isn't it? Yes? Anybody? Yes? If I plug in x is 3, what is 3 minus 3? What is 3 minus 3? 0. So that's a double root at x equal to 3. So now I know that I need to draw something that looks like a W. So then, if we draw it, we gotta use our root. X equal to 0 is a root. X equal to -1 is a root. And x equal to 3 is a root. Now you just become kind of an artist, and you're trying to figure out, like, how can I draw a W knowing these 3 points only? Knowing these 3 points only. So I know that this on the left is going to what? It's going to do what? It's going to do what? Shoot up, isn't it? Look, is it a W? It's going to shoot up like that? Something like that? What is it going to do on the right side? It's going to go up as well. It's going to shoot up something like that. And then we don't know how low it goes, but it's going to turn sometime. And it's going to go right through. These are single roots at -1 and 0, -1 and 0. I don't know how high it goes, but it's going to turn around. And what is it going to do at 3? It's going to bounce. And there's the graph. Without a graphing calculator, that's maybe what it looks like. It's a 4th degree polynomial that looks like a W. All right, next problem number 3. Good, problem number 3. All right, we're almost done. We got 3 and 4 and we're done for today. So we're going to do the opposite. They give you a graph, and now you're going to find the equation of the graph. What's the degree of this polynomial? It's a 3rd degree, isn't it? Yes, because it's sideways S, it's like an N looking thing. So it's a 3rd degree polynomial. So so it has to have 3 solutions. 3 solutions. So it looks like it has 3 rational solutions. And it seems like they're all single roots. The first one is going to be which one? X equals what on the left? Huh? X, they're all single roots. Because they all go right through, single roots. Single root at x equal to -2. Let me read what it says first. Write the equation in factor form of least degree for the following polynomial graphs. Least degree means that the a value is 1. That's why they say least degree. A equal to 1. So it has a single root at x equal to -2. another single root at where? X equal to 0. And another single root at x equal to what? Positive 3. Now we have identified the roots. We want to put it in function form by rewriting it in factor form. So how do we rewrite it in factor form? Let's see, how do we rewrite this in factor form? How do I rewrite the first one in factor form? What do? Add 2 to both sides. Can I already write it down as x plus 2? Yes? Yes? So if I subtract 0, wouldn't it be x minus 0 is just x? So it's just x. So I'm going to put it right here in the front. And the last factor will be what? X minus 3. And with least degree, a equal to 1, there's a 1 right here in the front. There's no need to put a 1. And just set it equal to f of x. And if I go on a graphing calculator and I put this in the graphing calculator, it will give me this. Last one. Last one for today. Okay, so if single roots go right through, the x-axis, because that's what this one's doing, went right through, and went right through, and went right through, there's single roots, and double roots bounce off of the x-axis, they bounce off. Triple roots, let me see, who knows football? Who's pretty good at football? Who knows, the coach says, hey, watch out. That receiver is going to do a stop and go. Who knows what I'm talking about? Do you know what I'm talking about? Huh?
Yes.
So the receiver is going to do this. The receiver is going to go, is going to run, is going to kind of stutter, stop, and go. It's going to sit and go. Call it sit and go. Sits and goes. Oh, that is a triple root. Yes or no? No? Ivan, you don't see it?
No.
Yeah. Okay, so that one has a double root, and it has a what? Triple root. That's all it has, a double root and a triple root. Single root. Does it have any single roots? Does it have any single roots?
No.
And the answer is no. None. Where's the double root at? Where is the double root at? X equal to 0. Where is the triple root at? X equal to 2. So now we got to rewrite them in factor form. So it's going to go subtract 0. X minus 0 is just x. So we're going to just go ahead and write down x. And what are we going to put as the power of x? It's a double root. What do I put as the power of x? Squared. So what are we going to do with the triple root? Put it in factor form first. What would it be in factor form? What? What are we going to do to put that triple root in factor form? We're going to subtract 2. Yes, subtract 2. It's going to become what? X minus 2 to the power of 3. And A is 1, and we set it equal to what? That's it, f of x, no? And we are done. All right.